Hello, my students, how are you? Today we'll solve sixth week, talking about algebra, ratio, and geometry. The ratio and distance between 2 points. Look at with me about question number 1. If 2x minus 3, 2x minus 5 equal 1 over 4, then find the value of x. In this example, to find the value of x, we must use the rules. The product of extremes equal product of means. We have 2x minus 3, 2x subtract by 5 equal 1 over 4. Using the rule, the product of extremes equal product of means. We can write 4 product by 2x minus 3 equal 1 product of x minus 5. And then, using distributive properties here, 4 times 2x will be 8x. 3 times 4 it will be 12. And we have x minus 5. Then move x from right hand side to left hand side and change the sign here. X subtract from 8x will be 7x. Subtract by 12 equal negative 5. And then move negative 12 from left hand side to right hand side and change the sign here. This 7x will be equal negative 5 plus 12. Okay, move negative 12 here. And then 7x will be equal 7. Then you can divide it by 7 to find the value of x. It will be 1. X here will be equals 1. Next question. Number 2. If E to B to C 1, 2, 3. The ratio between E, B, and C 1, 2, and 3. And B plus C equal 20. We can eat B plus 3, B plus C, 2 plus 3 equals 5, because B plus C equals 20. Okay, you want to find the value of A and B and C. We have ratio between A and B and C. We can find the value of A here by using the product of extremes equal product of means, or 1 times 20 divided by 5. 5 times 4 equal 20, and 1 times 4 equal 4, then the value of A equal 4. Right, 20 product by 1 over 5. The result will be equal 4. And P equal 2 product by 20 over 5. 40 divided by 5 equal 8. And then you can find the value of C. 3 times 20 divided by 5. 20 divided by 5 equal 4. 3 times 5, 3 times 4 equals 12. So the result will be 12, the value of C. So question is number 2. Question number 3. Find the number. If it's added to the two terms of the ratio 5 to 11, it will be 4 to 7. Put the number will be x. Put x the number. Put the number equal x. Okay, we want each this number to 5 and 11. 5 plus x over 11 over x. The result will be 4 over 7. And then 7 product by 5 plus x equal 4 product by 11 by x. And in doing the distributive properties, 5 times 7 equals 55, and 7 times x will be 7x. 4 times 11, 44, and 4 times x will be 4x. Now move 4x from right hand side to left hand side, change the sign here. 7x minus 4x it will be 3x. And 35 subtract from 44 it will be 9. And then you can divide it by 3 to find the value of x. Then the value of x here it will be 3. Okay, then the number will be equal 3. This is the number, okay? The number will be equal 3. Which is the number 4. Find the positive number if its square is added to two terms of ratio 7 to 11, it will be 4 to 5. Put the number equal x, and we will add it to square of this number. Square of this number, it will be x power 2. to the ratio 7 to 11. 7 over 11, 8 here x power 2 and here x power 2, then the result will be 4 over 5. And then you can using properties, the product of extremes equal product of means. 4 product by 11 plus x power 2 and 5 product by 7 plus x power 2. 4 times 11 will be 44 and 4 times x power 2 will be 4x power 2. 5 times 7 equals 25 and 5 times x power 2, 5x power 2. And then we have here 44 subtract by 35, it will be 9. And 4x power 2 subtract from 5x power 2, it will be x power 2. Then the value of x, we can write square root of 9, it will be 3. He tell us the example, positive number, it's meaning negative, it's wrong, okay? So the value will be 3. Then the number will be equal 3. That was questions number 4. Now, question number 5. Two integers, the ratio between them is 2 to 3. If 7 added to the first and 12 subtract from the second, then the ratio becomes 5 to 3. Then find the two integers. Okay. In this example, we have two ratios, 2 to 3, about first and second. Put first will be equal to x, and second number will be equal 3x, because the ratio between first and second will be 2 over 3. The ratio between first and second. Then the first number will be 2x and second number it will be 3x. Okay. And if 7 added to the first number, we have first number 2x added to 7. And 12 subtract from the second. Second here is the x subtract by 12. Then the ratio become 5 over 3. And then you can use the rules here, product of extremes equal product of means. 3 product by 2x plus 7 equals 5 product by 3x subtract by 12. And then using distributive properties, 3 times 2x it will be 6x, and 3 times 7 will be 1. 5 times 3x will be 15x. Subtract by 5 times 12 equals 60. And then you can simplify it by moved 6x subtract from 15x will be 9x. And negative 60 moved here it will be positive 21 plus 60 it will be 81. And then we can divide it by 9 to find the value of x. X here will be equal 9. In the value of x 9, so we can find the first number and second number. The first number to be 2 times 9 equal 18, so we have 18 first number, and second number 3 times 9 equal 27. So the two numbers will be 18 and 27. Understood? Question number 6. If x power 2 subtract by 2 over x power 2 plus 11 equals 3 over 4, then find the value of x. We have x power 2 subtract by 8 over x power 2 subtract or plus 11 equal 3 over 4. We want to find the value of x. We know the product of extremes equal product of means. You can write 4 product by x power 2 subtract by 8 equal 3 product by x power 2 plus 11. 4 times x power 2 it will be 4x power 2 subtract by 4 times 8 equals 32. 3 times x power 2 it will be 3x power 2 and 3 times 11 equals 33. And then 3x power 2 subtract from 4x power 2 to x power 2 and moved negative it will be a positive. 33 plus 32 it will be 65. 3 plus 3 it will be 5 and 3 plus 3 equal 6. And then we can find the value of x here by positive or negative square root of 65. Question number 7. Find the number if it is subtracted from antecedent of the ratio 15 to 13 and is added to the consequent, it will be 3 over 4. We have 15 over 13. This antecedent, number, and consequent. If we add it to consequent and subtract it from antecedent, then the ratio will be 3 over 4. So you can use here the product. 4 product by 15 subtract by x equal 3 product by 15 plus x. 4 times 15 equals 6 subtract by 4 times x will be 4x. 3 times 13 will be 59 and 3 times x equals 30x, 3x. And then negative 4x plus will be moved here positive. 4x plus 3x will be 7x. And 60 subtract by 39, it will be what? We have 10 minus 9, it will be 1. And 5 minus 3 equals 2. Then you can divide it by 7 to find the value of x. The value of x here will be 3. Okay, so the number will be equal 3. Let's question number 7. Look at with me about question number 8. Prove that the triangle ABC, which A point 4 and 5, B 3 and 2, and C the order negative 3 and 4, is right angle triangles, then find surface area. Okay, we can find the length of all sides such that AP. We can find the length of E by using the rule square root of x2 power 2 x2 minus 1 power 2 plus y2 minus y1 power 2. Okay, look at this here about AP square root of, we have here 2 minus 5 4 power 2 and 3 minus 4 power 2. Okay, we can write y2 minus y1 power 2 and x2 minus x1 power 2. I replace this. Okay, then the result will be we have here 9, 3 power 2 9, and negative 1 power 2 it will be 1. The result will be root 10. It's a length of AP. And what about BC? We can use the rule about BC. Look at with me here. We can write 3 minus 3. It will be 3 plus 3 power 2, because 3 subtracted by negative 3, it will be positive. Negative times negative positive plus. We have 2 subtract by 4 all power 2. And then we can find the length of BC. 3 plus 3 equals 6. 6 power 2 equals 36, and 2 minus 4 negative 2 power 2, it will be 4. The result will be equal 36 plus 4 equals 40. We know 40 equals 2 root 10 in the simplest for length unit. Okay, we get the result here. It will be 2 root 10. And what about the length here of AC? AC, we can find the square root of, we have A and C. Look at with me, negative 3 subtract by 4, it will be negative 7 power 2. Again, negative 3, look at here, negative 3 subtract by 4, it will be negative 7 all power 2 plus 4 subtract by 5. 4 subtract by 5, okay, it will be 4 minus 5, it will be negative 1. 4 minus 5, negative 1 power 2. And then you can write the result, square root of 49 plus 1, it will be root 50. So the result here will be root 50. And then you can prove that AC power 2 equal BC power 2 plus AP power 2. Then this right angle triangle by using the rule. Then triangle ABC is right angled triangle. It's right angle triangle, okay? Then ABC is right angle triangle. And then you want to find the area. The area of rectangle triangle here will be half times base times corresponding height. The base here, it will be what? We have AC is hypotenuse, okay? AC is hypotenuse, and B is right angle triangle here, B. And then we can write half times BC times AB. BC here was BC was root 40. Root 40, and we have BC root 40, and AP was root 10. AP root 10. Okay. And then the area will be equal half product by root of 400. Half of square root of 400, it will be 20. Half of 20, it will be 10. Then the area, it will be 10 square roots. The area equal 10 square units. The area will be 10 square units. Next question, number 9. Find the distance between point and the original point. We have point -3 and 4, and original point 0 and 0. Then we can find the length between them by using the rule. -3 minus 0 will be -3, and 4 minus 0 will be 4 power 2. The result will be 9 plus 16. It will be 25. The result will be 5 length unit. Question number 10. Prove that the point A, B, and C are collinear. Collinear C meaning in the same straight line. First step, we can find the length of A, B, and BC, and if the greater will be equal to parts, so the 3 points will be in the same line or collinear. So you must find the first length of EP. EP here, look at with me, E and B, we can write 4 minus 1 power 2, it will be 3 power 2. And here 3 minus 1 power 2. We have 3 power 2, it will be 9. 3 minus 1, 2, 2 to power 2, 4. Then the result will be square root of 13. It's the length of EP. And what about BC? B and C, negative 5 minus 1 power 2, and negative 3 minus 1 power 2. Negative 5 minus 1 will be negative 6 power 2, it will be 36. And negative 3 minus 1, negative 4 power 2 equals 16. We can add them. 6 plus 6, 12. 2 at the carry of 1. 2 plus 3, 5. The result will be 13 times 4 equal 13 times 4 equal 50. Then the result will be 2 root 3. Okay. And we can find the length of AC. A and C here. We have 4 minus minus 5. Right. Negative 5 minus 4 or power 2. And 3 minus negative 3 minus 3 here. Again, we have the point A, 4, and 3. Okay. And B was 1 and 1. And the point C, negative 5 and negative 3. We have negative 5 minus 4 and negative 3 minus 3 or power 2. Then the result will be negative 5 minus 4 will be negative 9 power 2 will be 81. Negative 3 minus 3 to negative 6 power 2 will be 36. Then 6 plus 1 7 and 3 plus 8 equal 11. We have 117 and here 52 and here 31. Or 17 here we can write 9 product by 13. The result will be 3 root 30. And we have here 2 root 13 and here root 30 length unit. So we know AC will be equal to side length BC plus side length AB. Okay, understood. Very easy. Then ABC are collinear, the same straight line. Next question. Question number 11. Prove that triangle whose vertices are A, B, and C are isosceles triangle. Isosceles triangles mean we have two sides equality. So you can find AB and BC and AC and then look at three sides. We must find two sides equal in the lenses. So we will write here, we have the point A was 1 and negative 2, and point B negative 4 and 2, and point C 1 and 6. First step, I will find A, B, square root of negative 4 minus 1, it will be negative 5 power 2, and 2 minus minus 2, it will be 2 plus 2, 4 power 2. So the result will be square root of 25 plus 16. 6 plus 5 equal 11. 1 and carry up 1, 2 plus 2, 4. The result will be 41. Square root of 41. It's AB. And what about BC? BC, square root of BC, 1 minus minus 4, it will be 1 plus 4, it will be 5. 5 power 2 to be 25. And we have negative 2 minus 2 to negative 2. Negative 2 minus 2, negative 4. Power 2, it will be 16. So the result will be 6 plus 5, 11. 1 and the carry of 1, 2 plus 2, 4. Square units. So we have two sides equality, but first you must prove that an equality is true. The sum between two any sides equal the result greater than the third. We have an equality of any triangle. If we add two sides each together, then the result will be greater than the third. So you must find AC like this. By using the rule, we have A and C. We have 1 minus 1, it will be 0, power 2 to be 0. And negative 2 minus 6 will be power 2. We can write square root of 0, and here negative 2 minus 6, it will be negative 8 power 2 equals 64. Square root of 64 equal 8. If we add any two sides, the result will be greater than the third. So, such that AC plus BC will be greater than AB. Then ABC is a triangle. So the first step, we must prove that ABC is triangle by using the inequality. If we add two sides, the result will be greater than the third. So A and B and C, we can use it to draw triangle, and then we have two sides equality. AB equal BC, then AB will be equal AC in the lenses. Understood? Next question. Number 12. If A negative 2 and 2 and B equal 1 and negative 1, then prove that the point M lies on x-axis of symmetry, the axis of AP. Okay, he wants to prove that the point M, and he gives us the point M lies on the axis symmetry of AP. Okay, we have point A and B, and the point M, we must prove that the point M lies on the AP line segment, such that here. If we prove that EP equal AM plus MB, then M lies in the line segment EP. Understood? You want to prove that the point M lies on axis, not axis symmetry, okay? On the axis of symmetry AB line segment here. Then we must prove that AB equal AM plus MB, or we can write AM equal AB plus BC. What is the type by using the results? First step, you can find the length of AB and AM and MB. So we have 3 points here about question 12. It's not in between them, but we have a line symmetry of AB, so you can write in outside or inside the line segment. Okay, we have here A was negative 2 and 2, and point B, the order of B equal 1 and negative 1, and point C, the order of it or M was equal 3 and 4. So first step, we can find the length of EP AP here. Negative 2 minus 1, it will be negative 3. Okay, negative 3 power 2, it will be 9. And 2 minus minus 1, it will be 2 plus 1. 2 plus 1 equal 3. 3 power 2, it will be 9. The result will be 9 plus 9, it will be 9 times 2, it will be 3 root 2. Length unit. And what about PC? PC here, BM, we can write 1 minus 3, it will be negative 2. Negative 2 power 2, it will be 4. And negative 1 minus 4, it will be negative 5. Negative 5 power 2, it will be 25. Then you can write the result here, square root of 29 length unit. And what about MA? MA here, it will be 3 minus minus 2, it will be 3 plus 2, 5. 5 power 2, it will be 25. Okay. Plus 4 minus 2, it will be 2. 2 power 2, it will be 4. So the result will be here, square root of 29. Then BM equal MA, it's quality. Then BM equal MA. BM equal MA in the length. So M is falling to the line segment BA. Understood? Because BM equal MA. There are 29, square root of 29, and here square root of 29. So it will be lies on the line symmetry of BM. Then we have MA will be equal MB. It's line symmetry of the line segment EB. It's line symmetry here. We call this the line symmetry. Okay, do you know the line symmetry? Simulate the line which perpendicular to the EP and bisect each together two parts. So M here. So the list of MA equal MB. Understood? So this example M lies in the line symmetry of AP. Because MA equal MB. Question number 13. Find the length of diameter of the circle whose center M2 and 7 and passing through negative 1 and 3. Okay, we have the circle and the center. We want to find the diameter of the circle whose center M was 2 and 7 and passing the point E. Finds point E negative 1 and 3. Okay, we want to find here the diameter. To find the diameter here, you can find the length of radius. MA, we called it radius. Okay, we can find the radius MA. How? By using the rule. MA equals square root of 2 minus minus 1, it will be 2 plus 1 equals 3. 3 power 2, 9. And 7 minus 3, it will be 4. 4 power 2 equals 16. So the result will be square root of 25 equal 5 length unit. It was MA. Then diameter equal twice MA, twice of 5, it will be 10 length unit. Next question number 14 is the distance between 2 points and 7, negative 2 and 3 equal 5 units, and then find the value of A. Okay, we can use the rule here, square root of A subtracted by negative 2, it will be A plus 2 power 2, and 7 minus 3 all power 2. The result will be 5 units. So we can write left hand side power 2 and second left hand side power 2. Then we can cancel square root 2 by power 2 from left hand side and right hand side. Then the result will be A plus 2 in power 2 plus 7 minus 3 equal 4. 4 power 2 equals 16. And 5 power 2, it will be 25. And then we have A plus 2 or power 2 equal 25 minus 16, it will be 9. And then you can cancel this power by put square root to left hand side and right hand side. Then the value of A plus 2 will positive or negative square root of 9, it will positive or negative 3. Then a plus 2 will be equal 3, or a plus 2 it will be equal negative 3. In the value of a here equal 1, and here is the value of e, it will be negative 5. Move the 2 here to left hand side, from left hand side to right hand side, and change the sign. Negative 2 and negative 3 will be negative 5. It was question 14. And what about question 15? Prove that A, B, C, D are vertices of rectangle and find the length of its diagonals. Okay, to prove that ABC is rectangle, first step you must prove that ABC is parallelogram and then put the properties of rectangle. We know that for a rectangle, all angles are equal in measures, and the measure of each one of them equal 90 degrees. So first step you must prove that ABCD is a parallelogram. Okay, how we solve it? We can solve it by finding the lengths by AB equals square root of, look at with me here to solve this. Okay, I will write AB subtract between 5 and negative 1. 5 minus minus 1, it will be 6. 6 power 2, it will be 36. And we have 1 minus 3, it will be negative 2. Negative 2 power 2, it will be 4. The result will be equal square root of 40. And what about BC? Here 4 and 6. And write 6 minus 5. 6 minus 5, look at here, 6 minus 5, it will be 1. 1 power 2 equal 1. And 4 minus 1, 3. 3 power 3, it will be 9. So the result will be square root of 10. It's BC. And CD, square root of 0 minus 6, it will be negative 6. Power 2 equals 36. And 6 minus 4, it will be 2. 2 power 2, it will be 4. The result will be square root of 40. And what about DA? D and A, look at here, negative 1. Look at negative 1 and 0. Negative 1 minus 0, negative 1 power 2, it will be 1. And 6 minus 3, it will be 3. 3 power 3, it will be 9. Then the result will be square root of 10. So we have two sides equality and two sides equality. Square brackets about parallelogram. Each of the sides are equal in length. Okay, we have ABCD. Then, right, such that AB equals CD and BC equal DA. Then ABCD is a parallelogram. It's a parallelogram. Okay, ABCD is a parallelogram. And then you can prove that ABCD rectangle by put the properties of rectangle. The properties of rectangle, two diagonals are equal in lengths. So you must find the lengths of AC and BD and prove that AB equal CD. Okay, I will complete here. I will find the lengths of AB, EC, and the lengths of BD. Look at with me about steps. AC, EC, where look at here by mouse here, E and C. 6 minus minus 1, it will be 6 plus 1, 7. 7 power 2, it will be 49. And here 4 minus 3, it will be 1. 1 power 2, it will be 1. Then the result will be root 50. And what about B and D? Look at here, 0 minus 5, negative 5 power 2, it will be 25. And 6 minus 1, it will be 5. 5 power 2, it will be 25. Then the result will be square root of 50. It's equality. We have two diagonals here equal in lengths. Then the ABCD parallelogram, the parallelogram ABCD is a rectangle because two diagonals are equal in length. Then we write EC equal BD, and then ABCD is a rectangle. Okay, understood. Then ABCD is a rectangle. It's the first one. Now we will complete the type of the examples from C at home. Okay, question number 1. Find the number if it is added to the two terms of the ratio 7 to 11, it will be 2 to 3. With the number x is added to the ratio 7 to 11. Put x here and x here. The result will be 2 over 3. And then using the rule, the product of strings equal product of means. Here we can write 3 product by 7 plus x equal 2 product by 11 plus x. And then 3 times 7 will be 21, and 3 times x equal 3x. 2 times 11 will be 22, and 2 times x will be 2x. And then move here, 2x subtract from 3x will be x. And 22 subtract by 21, it will be 10. Here 2 minus 1 will be 1. The result will be 1. 22 subtract by 21, it will be 1. Then the number will be equal 1. It was question number 1. Question number 2. Find the positive number. If it is square, it's added to two terms of ratio 6 to 11, it will be 3 to 4. Okay, put the number x and square root of this number, it will be x power 2. If we add it to numerator and denominator, about 6 and 11, we have here x power 2 and here x power 2, then the result will be 3 over 4. And using the rules here, the product of strings equal product of means. We have 3 product by 11 by x power 2 equal 4 product by 6 plus x power 2. And then using distributive properties, 3 times 11 will be 33. 3 times x power 2 will be 3x power 2, and 4 times x equal 24. And 4 times x power 2, 4x power 2. And then 3x power 2 subtract from 4x power 2 to x power 2, and 33 minus 24, it will be 9. And then the value of x square root of 9, and he tells us in the example it's a positive number. Positive, it's meaning negative, it's impossible. So the result will be 3. In the number here, it will be equal 3. It was question number 2. Now we will solve the question number 3 here. Question number 3, if x minus 5 to 5x plus 5 equal to 3, and then find the value of x here. We can write up here x subtract 5 over 5x subtract or 5x plus 3. The result will be 2 over 3. And using the rules here, the product of strings equal product of means. Write 3 product by x subtract 5 equal 2 product by 5x plus 3. And then 3 times x equal 3x, 3 times 5 equal 15. 2 times 5, 10, and 2 times 3 equals 6. So you can find the difference between 10x and 3x will be 2x. Move the hair from right hand side to left hand side and change the sign. And then write equal 6 plus 15. It will be what? It will be 21, okay? Using steps again, okay, x minus 5, and here 5x plus 3, 2 times 5, 10, 2 times 3, 6, 3 times x, and 3 times 5, 15. Move the here, this number will be 21, and the example we moved, it's 10x, okay? Again, it's 10x, not 1x. Move the here, it's 3x, subtract from 10x, it will be 7x, and negative 6 plus negative 15, it will be negative 21. Then the value of x, it will be negative 3. Okay, put here negative 3, it will be negative 8. To prove that the result will exactly put x equal negative 3. Negative 3 plus 5 will be negative 8. And negative 3 times 5, negative 15. Negative 15 plus 3 equal negative 12. And we can simplify by divided by 4 numerator and numerator. It here 2 over 3. So the result will be 2. The result will be x here equal negative 3. It's the value of x. Or the number here, the integer number, okay, the value of x here will be negative 3. Now we will solve question number 4. Two integers, the ratio between them 3 to 7. If 5 subtracted from each of them. Okay, we have 3 and 7. It's the ratio between two numbers. The ratio between two numbers. Then the first number will be 3x and second number will be 7x. If we subtracted from them, subtracted 5 from first and second term, antecedent and consequent, because the ratio between them is 3 to 7. So the first number will be 3x and second number will be 7x. If we subtract 5 from numerator and numerator, the result will be 1 over 3. And then we can use the rules: 3 product by 3x minus 5 here, and 1 product by 7x minus 5. 3 times 3 equal 9, and 3 times 5 equal 15. 1 times 7x equals 7x subtract by 5. 7x subtract from 9x will be 2x. And negative 15 moved here, 15 minus 5 it will be 10. Then you can divide it by 2 to find the value of x here, it will be 5. Then the number will be 3 times 5. First number 3x, and second number was 7x. Then the numbers will be equal 3 times 5 equal 15, and 5 times 7 equals 35. Then the two numbers will be 15 and 35. Okay, 15 and 35, two numbers. It was questions number 4. Questions number 5. Find the number which, if 3 times of it is subtracted from each term is of the ratio 49 over 69, it will be 2 over 3. Okay, we will put the number x, and 3 times number, it will be 3x. If we subtract it from each term is subtracted about 49, it will be subtracted by 3x, and 69 subtract by 3x. So the result will be equal 2 over 3. And then product 3 times 49 subtract by 3x, and 2 product by 69 subtract by 3x. Now 3 times 49, 3 times 9 equal 27, or 7 and the carry of 2. 3 times 4, 12, plus 2 equal 14, subtract by 3 times 3 equal 9. 2 times 9 equal 18, 8 and the carry of 1. 2 times 6, 12, plus 1 equal 13, subtract by 2 times 3 equal 6. And then negative 9x moved here, it will be 9x subtract by 6x, it will be 3x. I move this number here. 17 minus 8, it will be 9. 3 minus 3, 0, and 1 minus 1, 0. Then the value of x here, we can divide it by 3. Then the value of x here equal 3. Okay, so the number will be equal 3. Here's question number 5. Now we will solve question number 6. If ratio ABC 5723, A, B to C, the result will be 5 to 7 to 3. And A plus B, we can A plus B was 27.6. Then we can add 7 plus 5 equal 12. To find the value of A using the rule product of strings equal product of means, then 5 product by 25.6 over 12, and the value of B equals 7 product by 27.6 over 12, and value of C equal 3 times 27.6 over 12. And we can use the computer to find the result about this example. Here 5 times 27.6 divided by 12, the result will be 11.5. And here 7 will be 16.1, and here 3 times 27.6 divided by 12 will be 6.9. Understood? Next question. Next question, number 8. Determine the type of triangle ABC which respect the length of each side. Okay. We asked about the triangles here, isosceles or scalene or equilateral triangle. So to prove that, first step, we must prove that the sum of two sides is greater than the third. To do that, you must find the length of all sides first, such that AB equals square root of what? We have here AB. We can write negative 4 minus 1 or power 2. And 2 minus minus 2, it will be 4 power 2. Then AB negative 4 minus 1 to negative 5. Negative 5 power 2 to be 25. 4 power 2 equals 16. So AB equals 6 plus 5 equals 11. 1 declare 1, 2 plus 2, 4. It's AP. And what about the length PC? The length of PC here we have 1 subtract by negative 4. It will be 1 plus 4. It will be 5. 5 power 2 to be 25. And 6 minus 2, 4. 4 power 2 equals 16. It's PC. Okay. And the length of AC, look at here about A and C, we have 1 minus 1, it will be 0, 0 power 2 equals 0, and 6 minus minus 2, it will be 6 plus 2 equals 8, 8 power 2, it will be 64, okay, 8 power 2 equals 64. So you can find the length, which one, here, square root of 41, length unit, and here, square root of 6 plus 5, 11, 1 and the capital, 2 plus 2, 4, length unit, and here, equality, then, such that AP plus PC is greater than EC. You must prove that first. The sum of two any sides in triangle is greater than the third. You must prove that first, okay? And then you know that here AP equal PC. Then AP equal PC equals square root of 41. Then APC is isosceles triangle. This triangle we call it isosceles. It's triangle APC and isosceles triangle. We call it isosceles triangle because we have two sides equal to the lenses. It was question 8. And what about question number 9? ABCD is quadrilateral where A, B, and C and D, then prove that ABC square and find the area. First step, we want to prove that ABC square. First step, you must prove that ABCD is parallelogram, and then prove that two sides are equality about the two diagonals, and you can write the two diagonals bisect each other, or all sides equal lengths. If all sides equal lengths or two adjacent sides equal lengths in the parallelogram, it will be converted to rhombus. And if you prove that two diagonals equal lengths, it will be rectangle. So if we prove that two properties exactly in parallelogram about all sides equal lengths and two diagonals equal lengths, so it will be square. So prove that. Square first step, you must prove that. Prove that it will be parallelogram and then rhombus. Prove that parallelogram will be rhombus and then prove that it will be rectangle. Okay, we have 3 steps to solve this example. First step, you must find the list of AB and then BC and CD and DE, and the list of, we have here A, B, C, D, and then we can find the list of two diagonals EC and BD. Okay, first step, I will solve it with you here. Look at with me the mouse here and pay attention about numbers. Okay, it was question number 9. Pay attention about steps. Okay, my students, we have here A and B. We have negative 3 minus 2, it will be negative 5 power 2, it will be 25, and 0 minus 4, negative 4 power 2 equals 16. The result will be square root of 41. And what about BC? B and C here, negative 3 minus 3, it will be negative 3 plus 4, negative 3 plus 3 equal negative 4 power 2 equals 16. And 5 minus 0, 5 power 2 equals 25. Square root of 6 plus 5 and 1, declare 1, 3 plus 2, 4. And what about C and D here? We can write negative 2 minus 7. Minus 7 will be negative 2 plus 7. Negative 2 plus 7 power 2. Negative 2 plus 7 it will be 5. 5 power 2 it will be 25. And 5 minus 9 it will be negative 4. Negative 4 power 2 equals 16. So the result will be 41. Length unit. And dA, we have D, and A, we have 2 minus minus 2, it will be 4. 4 power 2 equal 16. And 4 minus 9, it will be negative 5. Negative 5 power 2, it will be 25. The result will be square root of 41 lines unit. And AC, we have negative 7 minus 2, it will be negative 9 power 2, it will be 81. 5 minus 4, it will be 1. So the result will be square root of 82. And BD, E and D, we have negative 3 minus minus 2, it will be negative 3 plus 2, it will be negative 1 power 2, 1. And we have 0 minus 9, it will be 9 power 2, it will be 81. So the result will be square root of 82 lines unit. Then we prove that EP equal BC equal CD equal DA. Then ABCD is a parallelogram, all sides, and you can write opposite sides equals to prove that parallelogram. Write ED equal BC and EB equal DC, and then EB equal BC. First, understood. First step proves that it's parallelogram, and next step proves that it's rhombus and rectangle. AB equal BC equal CD equal DE, and we have two diagonals equality AC equal BD. Then ABCD is ABCD is a square. Understood? Because we prove two properties here. First, prove that parallelogram, and next step prove that each of the sides are equal on lenses. Question number 10. If A, X and 3 and B, 3 and negative 3 and 2, C, 5 and 1, and AB equal BC, then find the length value of X. Okay, first step, we can find the length of AB here. A and B, we can write X minus 3 power 2 and 2 minus 3 power 2. Okay, the result we can sample it, right? X minus 3 power 2 and here 1. It was AB. And what about BC? We can write square root of B and C here. 5 minus 3 negative 2. 5 minus 3 2 power 2 4. And 1 minus 3 it will be 1 power 2. 1 minus 3, sorry, 1 minus 2 negative 1 power 2 1. So the result will be root 5 length unit, and here length unit. Then we can write equality between AP and BC. We have AP was equal BC. He gives this information in the example. And then you can write square root of X minus 3 power 2 plus 1 equals square root of 5. So we have two sides are equal lengths here. This side and here's the side equality. Then you can cancel square root by put the power from left hand side and right hand side. The result here will be 5, and the result here will be X minus 3 power 2 plus 1, and then moved 1 from left hand side to right hand side. Cancel negative 1 from left hand side, right hand side, but to change which, and you know the properties. So we have two solutions here. X minus 3 over power 2 equal 4, and X minus 3 over power 2 equal X minus 3 power 2 equal 4. Then X minus 3 equal positive or negative 2. We must put square root left hand side, right hand side, and sign here positive or negative. Okay, then we have two solution. X minus 3 will be equal to, or X minus 3 equal negative 2. Then the value of X here equal 5, and the value of X here 3 minus 2, it will be 1. Understood? We have two solutions about this number. Next question. was question number 10. Okay. Now question 11. Question 11. Prove that the points x, y, and z lie on a circle center. Is it point M, -1, -2, and 1? Then find the circumference of circle, or pi equal 3.4. Okay. To prove that the points x, y, and z lies on the circle, we must prove that mx equal my equal mz because all radius are equal lengths. So we have circle here, the point here m, and we have point A and B and C. To prove that A and B and C or XYZ, sorry, lies on the circle, we must prove that all sides are equal lengths. Then you must find the three lenses. First step, you can find mx. We have here, look at with me, the point of M was -2 and 1. And point B, point X, was 3 and 1. And point Y, order of 2 and -2. And Z was 2 and 4. So mx here, we can write 3 minus -2, it will be 3 plus 2, 5. 5 power 2, it will be 25. 1 minus 1, 0. The result will be here 5 lengths unit. And what about my, square root of my here, m, here, and y. Okay, pay attention with me. 2 minus -3 here, 2 minus -3, it will be 4. 4 power 2 equals 16. And here, -2 minus 1, we put here m and y, -2 and -1 will be -3. -3 power 2, it will be 9. Understood? Again, -2 minus 1 will be -3. -3 power 2, it will be 9. Result will be 5. Square root of 25, 5. Please. And what about Zm? Here, Z and M. 2 minus -2, it will be 4. 4 power 2 equals 16. 4 minus 1, it will be 3. 3 power 2, it will be 9. The result will be square root of 25 equal 5 lengths unit. And then we have mx equal my equal zm. Then the point x, y, and z lie on the circle. They are lying circle. Then we can find circumference. Circumference equal to pi r. It's the rule. So the radius here will be 5 length units. So we can write 2 product by 3.14 product by 5. 2 times 5, 10. 10 times 3.14 will be 31 and 4 tenths length unit. Okay, understood. Next question number 12. Choose the points A, B, C are not collinear. Not collinear, it's meaning AB not equal to the sum of two numbers, or the greater the number not equal to the smaller two numbers. So, first step, about this example, question 12, you must find the difference between A and B to find the length AB. Because AB, to find the length between AB, you must use the rule. So, I will write first here, all points first, to know the digits, and then I will solve with you, okay? Look at with me about steps. We have A, B, square root of 3 minus 5, -2 power 2, it will be 4. -7 minus 1, -8 power 2 equals 64. The result will be 64 plus 4 equals 68. And BC, B and C here, it will be square root of 3 minus 1, 2, 2 power 2, 4. -3 minus 3, it will be -10. -10 power 2, it will be 100. The result will be square root of 104. And what about CA? 5 minus 1, 4, 4 power 2 equals 16, and 1 minus 3, negative 2 power 2, 4. The result will be square root of 20. Then the greatest number here, BC, not equal to AB plus AC. Then A, B, and C, they are not collinear. Not collinear. Are not collinear. It's mean not in the same straight line. Not collinear, it's meaning they are A and B and C. They are is not in the same straight line. Maybe triangle, okay? They are not collinear. Question 13. Prove that A, B, C, D are vertices of parallelogram. Okay, to prove that A, B, C parallelogram, you must prove that each of the sides are equal lengths. Okay, or another lessons in the future you will get another properties to diagonal passage is other, and each of the sides are equal lengths and parallel. You can prove that only two sides parallel and equal lengths, but in this lesson, we can find the lengths about A, B, B, C, C, D, D, A, and prove that each of the sides are equal lengths. So I will write AB and BC and CA and ED. About question number 13, he gave us the point A, negative 1 and 1, the point B, 0 and 5, point C, 5 and 6, and point D, 4 and 2. We can find square root of here. AB, 0 minus minus 1 will be 1 power 2, 1. 5 minus 1, 4, 4 power 2 equals 16. Square root of 17. BC, 5 minus 0, 5, 5 power 2, 25. 6 minus 5, 1, 1 power 2, 1. The result will be square root of 26 means unit. CA, 5 minus minus 1 will be 6, 6 power 2 equals 36. 6 minus 1, 5, 5 power 2. We can find AB, BC, CD, CD, okay, and DA, CD, C and D. 5 minus 4, 1, 1 power 2, 1, and 6 minus 2, 4, 4 power 2 equals 16. The result will be square root of 17 length unit. And what about AD? 4 minus minus 1, it will be 5. 5 power 2, it will be 5. 2 minus 1, 1. 1 power 2, 1. The result will be square root of 26 length unit. Then we have two sides equality. Each of the sides are equal lengths. We have AB was equal to CD, and BC was equal ED. Each of the sides are equal lengths. Then ABCD is a parallelogram. Yeah, prove that. Parallelogram. Okay. Question 14. ABCD quadrat, which ABCD then prove that EBC is a rhombus and find the area. Okay, first step we must prove that. About question 14, ABCD a parallelogram first, and then prove that all sides are equal lengths to prove that it's rhombus. Okay, we have the point E, 3 and 3, and B, 1 and negative 1, and point C, negative 3 and 3, and point D, 1, negative 1 and 1. First step, we can find the length of AB about using the rule 3 minus 1, 2 power 2, 4, and 3 minus minus 1, 4, 4 power 2 equals 16. The result will be square root of 20. It will be 2 root 5 length unit. And what about BC? B and C here, 3, negative 3 minus 1, negative 4 power 2, it will be 16. And 3 minus minus 1, it will be 3 plus 1. 3 plus 1, okay? It will be 4. 4 power 2 equal here BC, negative 3 minus 1, negative 4 power 2, 16, and 3 minus minus 1, 4. 4 power 2 will be 16. And what about AB? 3 minus 1, 2, 2 power 2, 4. We have 3 and 3, 1 and negative 1, and 3 and negative, sorry, it's negative 3 here, okay, sorry, negative 3. Then, negative 1 plus 3, it will be 2, 2 power 2, 4. The result will be square root of 20. The result will be 2 root 5 length unit. And what about CD? C and D here, negative 1, negative 3, it will be negative 1 plus 3. It will be 2, 2 power 2, 4. And 1 minus minus 3, it will be 4. 4 power 2 equals 16. The result will be square root of 20. It will be 2 root 5 length unit. And what about DA here? Negative 1 minus 3, it will be negative 4 power 2 equals 16. 1 minus 3, negative 2 power 2, 4. The result will be square root of 20. It will be 2 root 5 length unit. Then AB equal BC equal CD equal DE. Then ABCD is a rhombus. It's a rhombus. Question 15. Determine the type of triangle ABC where ABC with respect to the measure of its angle. Okay, we want to determine about its angle. You can find the lengths of AB and BC and CA using about the rule. If the greater number power 2 equal the smallest first and second power 2, here it will be right angle triangle. So our first step proves that ABC is the vertex of triangle. Okay, we have point A was 1 and negative 1, and point B 2, B2 and negative B here 2 and 1, and point C was negative 3 and negative 2. First step, we can find the length of A, B, square root of 2 minus 1, 1 power 2, 1, and 1 minus minus 1 will be 2 power 2, 4. The result will be square root of 5. And BC, 2 minus minus 3, it will be 5. 5 power 2, it will be 5. 1 minus minus 2, it will be 3. Power 2, it will be 9. 25 plus 9, it will be 34. And CA, about negative 3 minus 1, it will be negative 4 power 2, or 2, it will be 16. Negative 2 minus minus 1, it will be negative 1 power 2, it will be 1. The result will be square root of 17. Again, AB, 2 minus 1, 1. 1 minus minus 1, 2. 2 power 2, 4. It will be 5. Length unit. And here, BC, 2 minus minus 2, 25 power 2, 25. 1 minus minus 2, it will be 3 power 2, 9. It will be 34 length unit. And here, AC, negative 3 minus 1, negative 4 power 2, 16. Negative 2 plus 1, negative 1 power 2, 1. Length unit. So, we can write BC, comparing between BC power 2, but first step, you must put this rule such that CA plus BC is greater than EB. Okay, the plus of two sides greater than the third. Okay, then ABC is right is triangle, but if we put BC power 2, comparing between the greatest number and the smallest two numbers, okay, comparing between them, BC power 2 and AB power 2 and CA power 2. We have the result here, it will be 34. And here 5 plus 17. 5 plus 17, because power 2 will be 5, power 2 will be 17, it will be 22. Then this triangle will be obtuse. Triangle ABC is an obtuse angle triangle. Obtuse angled, obtuse ABC is an obtuse angled triangle. obtuse angle triangle. Okay, let's finish about questions. Okay, goodbye. Understood my solution questions? We have first, solve first and second. Um, and the third here, we have it in the side, this sheet, and the next time I will solve it, okay? Okay, goodbye.